In this next video, we are going to discuss double replacement reactions, or at least we're going to start discussing double replacement reactions. We're going to split this into two different videos. But what I want us to focus on this second part of the video is how we know whether a double replacement reaction will occur or not. Double replacement reactions, remember, when we have two compounds and an element in each of those compounds, they simply trade places. Now, just because you put two compounds together does not mean that they're going to react. So what's the driving force? What are the causes for an actual reaction occurring? The first one, and the one that we're going to be focusing on this year, is the formation of a precipitate. This is a solid formed during a chemical reaction. And we're going to use a solubility chart to see whether a compound would actually form a precipitate, whether it would be insoluble in water or not. Now, the formation of a gas and the formation of a molecular compound such as water, those are important driving forces, but we're not going to really focus on those unless you take AP. We focus on those two driving forces in that course. So let's look at our compounds now in terms of whether they would form a precipitate if they were produced in a chemical reaction. Now, in order to tell this, we're going to need a solubility chart. And the solubility chart that you're going to be given is going to look like this. And what this says, if you'll look at the top of the solubility chart, this is for the soluble compounds. These are the compounds. If you see acetate, ammonium, nitrate, cyanide, any of these compounds listed up here, any of these ions listed here, they are going to result in a soluble compound, something that's going to dissolve in water. It's not going to form a precipitate. So these soluble compounds do not form a precipitate. They dissolve in water. And PPT is a common abbreviation for precipitate. You might as well get used to it now because you'll see it a lot. Insoluble compounds, on the other hand, if you'll look down here at the bottom, compounds that contain carbonate, phosphate, chromate, etc., these tend to form insoluble compounds. And if they form an insoluble compound, then they do indeed form a precipitate. Now, there are some exceptions. If you'll notice up at the top, some of the beginning ones, there are no exceptions. If NH4 or NO3 are in a compound, then they are going to be soluble. They are never going to form a precipitate. There are no exceptions. But what if it's bromine or chlorine or iodine or sulfate? If those ions are present in the compound, then we need to know a step further. We need to know what they're being paired with. Because exceptions, for instance, for bromide up here, if you'll look at the common exceptions, silver, lead, and mercury 1. Those three ions, if they are with bromine, would result in an insoluble compound. They would form a precipitate. So these over here are going to result in insoluble compounds. Now, on the bottom, we've got some exceptions again. We've got all of these compounds, or excuse me, all of these ions here at the bottom, and they are insoluble unless they have one of the exception elements or polyatomic ions with them. Notice what our exceptions are every single time. Compounds of NH4, that shouldn't surprise you since we just said up at the top that all NH4 plus, all ammonium compounds are soluble, always, there are no exceptions. And all of the alkali metal cations. These are everything in group 1A. Those are going to be exceptions every time. Now there are a few other exceptions for hydroxide, for instance, and sulfide. But for our beginning ones, the only exceptions are ammonium and our elements in group 1A. So we can say then that the soluble ones are always going to be anything with ammonium, nitrate, cyanide, all of our chlorine polyatomic ions, everything that has a group 1A metal with them, those are always going to be soluble. So that's going to be the first thing we'll want to look for, because that's just a quick gimme on those. So that's how we read our solubility chart. So let's go back here and look at these compounds. First of all, we've got sodium chloride. The first thing you want to look for is one of the always soluble substances. Does this compound contain any of those ions, like ammonium or nitrate, or a group 1A metal? And if you'll notice, it does contain a group 1A metal. Since it does, this is going to be soluble. And remember what we said on the solubility chart. If it's soluble, it will not form a precipitate. No precipitate formed. Now look at the next one, AgCl. Again, you want to look for your common ions that are always soluble. Does this have ammonium, NH4, or NO3, or CN, or any of the chlorine polyatomic ions? Now, it's got chlorine in it, but it's not a polyatomic ion, so that doesn't count. Silver is not a 1A metal, so we're going to need to check the solubility chart. So let's go back to the solubility chart. Somewhere on this chart, we should be able to find either Ag or Cl. And if you look at the chart, you'll see that Cl is right here. It's in the soluble list, if you notice. It's in the soluble column. So it looks like it's going to be soluble, but we've got to check for our common exceptions. And look what one of our exceptions is. Silver. And since that compound has silver with chloride, that is going to be an insoluble compound. So let's go back here. This is insoluble. Does it form a precipitate? Yes, it does. These always pair up. If it's soluble, it's always going to be no for whether it forms a precipitate. If it's insoluble, it's always going to be yes. NH4, ammonium phosphate, NH4,3PO4. First thing again is to look for our common, always soluble ions. Does it have ammonium or nitrate? And why, yes, it does. Ammonium, NH4. It's got NH4 in it, which that's one of our always soluble ions. Check back on your solubility chart. So this is going to be soluble. And since it's soluble, it will not form a precipitate. Barium sulfate. Check the solubility chart. Does it have one of our common solubles, ammonium or nitrate or any of those? Look at our solubility chart. It does not have any of those. Barium is not a group 1A element, so either barium or sulfate should show up somewhere on here, and it does. Here's sulfate. Sulfate's in the soluble list. So at first glance, it looks like soluble, but let's make sure that barium's not an exception. And if we look over here, we see, yeah, barium is an exception. Since it is an exception, that means it's going to be insoluble. And if it's formed in a chemical reaction, it's going to form a nice precipitate and cloudy that whole test tube up. So barium sulfate is insoluble. And therefore, yes, it will form a precipitate. And finally, copper 2 nitrate. Check first for common soluble ions, ammonium, nitrate. There it is. As soon as it has nitrate in it, it's automatically soluble and will not form a precipitate.